Hello friends, welcome to this. Going to solve on problems relating to the electric potential. So let's start the class. So the question is taken from AIPMT, which was asked in 2014. The question is, in reason the potential is represented by Vxyz is equal to 6x minus 8xy minus 8y plus 6yz, where V is in volts and xyz are in meters. The electric force experienced by a charge of 2 coulomb situated at a point 111 is, so we are given here 4 options. So let's proceed to solve the question. So in this question, the potential is given as Vx, y, z. The potential is given as 6x minus 8xy, 6x minus 8xy minus 8y plus 6yz, right? So this is the potential given in this question. So we have a charge q is placed, a charge q is equal to 2 coulomb is placed at a point 111. So at that point we have to find the electrostatic force. Okay, electrostatic force. So আমি কি কনসিডার করিম ইয়াতে, suppose in a region we are given here the potential is given in terms of xyz, right? The potential is given xyz. Suppose this is x coordinate, this is x cap, means unit vector x, this is y cap, and this is z cap, right? So the potential is given xyz coordinate. So in this space potential is given, suppose in this space, right? It is from this is 0 0 0, so from here this is 1, y coordinate is 1, so z coordinate suppose here, suppose at this point phi 1 1 1 is given. So we have to find the electrostatic force at this point in this potential. So how to proceed? Since there is no direct relationship between electric potential and the electrostatic force, we have first relate electrostatic potential with electrical intensity. So we have to first relate with these two variables, with these quantities, right? Then after calculating E from the potential V, we can write the equations F is equal to QE. So if we can find the electrical intensity, we can easily calculate the electrostatic force. So keeping into this mind, let's first calculate the electrical intensity from this given potential. So the formula related to this electrical intensity with the potential is given as the negative differentiation, the negative derivatives of the potential with respect to the position. So if the position is x coordinate, then we can write it as a minus dB dx x cap. So why x cap? X cap is written here because the electrical intensity is a factor quantity, right? But we can see here that the potential V is given in terms of x, y, and z. So these relations we must have to write in case of 3 dimension, which is generally given the negative gradient of the potential, right? What is the value of gradient? This gradient is nothing but I cap del del x plus j cap del del y plus k cap del del z. So then V, right? So now let's calculate these quantities. So let's proceed and solve it in the next slide. So now we are having E is equal to minus I cap del x v plus z cap del y v plus k cap del z v, right? So the value of the potential is given as v is equal to 6x minus 8xy minus 8y plus 6yz, right? So from this relation, so if we want to find the first part of this equation, so which is del v over del x. So if we want to calculate this part, you see we are taking the partial differentiations of the potential with respect to x. So if we take the partial differentiation with respect to x, the other two variables y and z will remain as constant, right? So you see, other than x, the variables y and z will remain constant. So if we take the differentiations of 6x with respect to x, we will get only 6 here. In the second term, it will become as 8y because y is a constant here, and if we take the differentiation with the del x will become 1. So the next term will become 0. The last term will also become 0 because there is no any x term. So what we are getting from this differentiation, 6 minus 8y. Okay, so now the first term is calculated here. The second term, if I just calculate the second term, del v over del y, means we are now doing the partial differentiation with respect to the variable y. So the other variable x and z will remain as constant. So this first term will become 0, the second term will become minus 8x because x is constant now. The second term will be minus 8. The third term, the last term will become 6z. Clear? Now coming to the, this is now done. So coming to the last part is del v over del z. Now we are taking the partial differentiation with respect to the z. So the variables x and y are now constant. You see, this will become 0. First term will become 0 because here there is no any z component or z variables in the first term. Also there is no z variables in the second term. 3 number term to z নাই, so 0. কেৱল হেকৰটোতে আছে z, right? হেকৰটোত কি আছে 6yz আছে. so ইয়াত যদি আমি ডিফাৰেন্সিয়েচন কৰো কি পাম, 6y পাম, 6y পাম, হয়নে? so এটো আমি লাষ্টৰ টাৰ্মটো আমি কি পালো 6y. এটা যদি আমি এই সব ভ্যালু বিলাক যদি এইটো ইকুৱেশ্যনত বহাই দিও, therefore what will get the value of electric field intensity, it will minus I cap কিমান পালো del v del x 6 minus 8y, right? next term to কিমান পাম plus j cap কিমান আছে ইয়াত del v del y, right? del v del y value কিমান minus 8x minus 8 plus 6z. what will be the last term? Last term will be 6y k cap, right? So coming back to the question, the electric force is to be calculated at the point 1 1 1. so we are going to calculate the value of E at point 1 1 1. তেতিয়া আমি কি পাম চোৱাচোন, কি পাম ইয়াতে আমি বহাই দিম y value 1, x value 1, z value 1. then we will just write the equations, we will rewrite the equation because 6 minus 8 কিমান হ'ব minus twice I cap. ইয়াত কিমান হ'ব minus 8x minus 8 minus 8 minus 16 plus 6 minus 10 j cap, and the last term will become as 6 k cap. so this minus I will just put it inside. what will have become twice I cap, then plus 10 j cap, then minus 6 k cap, minus 6 k cap. Itu palo. Okay, so now let's find the electrostatic force, the relation between F and E is given by the charge, test charge generally, this charge is generally test charge, QE. Okay. From here, the value of the Q is given as 2, the E we are getting, the value of E is twice I cap, 5 J cap minus 6 K cap, right? This is the value of E. So we can take, what is the value of E? This is 10, not 5. This is 10. This is 10, not 5, right? This is 10. So from here we can take 2 as a common. So 2 into 2. আমি কি কৰিলো ইয়াৰ পৰা 2 কমন লৈছো, থাকিল কি I cap 5 J cap minus 6 K cap, right? So এটা আমি কিমান পালো 4 I cap plus 5 J cap minus 6 K cap. So this is the answer. So what are the option? Okay, the option is given in magnitude. We have to take the magnitude of this force. So if we take the magnitude of the force, the 4 will remain as same, and we will take the magnitude. So the magnitude of any vector is generally the square root. We have to take the square root, then we take the coefficient of each component of the unit vector and then we square them and add. So the coefficient of I cap is equal to 1, the coefficient of J cap is equal to 5, so 5 square plus coefficient. So if we take the common here, it will not become 6, it will become 3, right? It will become 3. So the coefficient of K will become as minus 3, so minus 3 square. So how much it will become, right? 1 plus 25 plus 9, right? So how much it will become? 26 and 9, it will become 35. So 35. The unit of force is Newton. So this is the answer. So the option 4 is matching with our answer 435. So option 4 is the correct answer. Thank you.